Pop Quiz HotShot. We're back. Lesson 4.2, part 2. And this time we're taking a pop quiz. Sorry. But we're going to make it a little bit easier than it says on here. It says the quiz consists of 5 multiple choice questions. Each question doesn't have 5. It has 4 answer choices labeled A through D. As you know, you can tell right there. Go ahead, fill in an answer to each of those. Hit pause, and I'll tell you how many you got correct after the break. Hopefully you answered B, and then D, and then D, and then A, and then B. If you did, then you got 5 out of 5 correct. Let's figure out the probability of getting 0, 1, 2, 3, 4, or 5 correct. So we're going to start and actually figure out, is this a binomial distribution setting that we've talked about last time? So first we're going to go through bins, B-I-N-S. The B stands for binary. Are there 2 outcomes? Yes. You can either be right or wrong. I stands for independent. Is each different question's probability of getting it correct independent from each other? Yes. Each answer, like if I answer question 1, whether I get it right or wrong does not affect how I answer question 2. Each answer does not affect the next question. After B and I, we have N. Do we have a set number of trials? Yes, we know that N is 5 trials. We have 5 questions, we have 5 trials. Finally, S. Do each question, each trial have the same probability? Yes. The probability of getting each of them right is there's 1 correct answer out of 4 answer choices for 0.25 or 25%. Next, we're going to calculate the probability of getting exactly 2 correct. I'm going to highlight that word, exactly 2 correct, and we're going to show our work. We have notes from last time. We're going to use this formula here. We're going to choose 5 questions. We're going to choose 2 correct. So we're going to have the probability of 0.25 getting it correct raised to the second power, 1 minus that 0.25 to the n minus k, the 5 trials minus the 2 correct. So let's jot all that down. We know that P is 0.25. We know that 1 minus P for the probability of getting something wrong is 0.75. We know that N is that there's 5 trials, and in this case we want to get a K of 2 correct. So we're going to write that down in probability notation. So we want the probability of getting exactly 2 correct, and that's going to be of 5 questions. We are going to take a combination and get 2 correct. We're going to multiply that by probability of getting 2 correct. So there's the probability of getting answer correct raised to the power of 2. And we're going to multiply that by 1 minus P, which we calculated would be 0.075 raised to the power of 5 minus 2, which means we'll get 3 wrong. So we're getting however many different combinations we can get 2 correct out of 5 times the probability of getting 2 correct times the probability of getting 3 incorrect. When we multiply all of this out, I recommend using the calculator. If you got one, we get 2.64. There is another way to do this on the calculator. It involves, let's write it down here on the calculator, it involves the TI-84. I don't know about your weird Casio calculators. It definitely doesn't work on the iPhone calculator. Who knows about Droid? But on the Droid, remember, you can download the TI calculator as well. I think it's called Calculate something. I don't know. It's on there, though. You can download it. Go Droids. On the calculator on the TI-84, we're going to hit second, and then we're going to hit bars, and then we're looking for either A or B. I can't recall, but one of them, A or B, is going to be binomial PDF, and that's for the exact number. So the numbers here we want is, this is going to be, it's going to be given to us as N, P, and the K. So we're going to fill that in. We know all those values. Binomial PDF, 5, 0.25, and 2. and that will get us the same value as 2.64 as well. Maybe I'll make a video tomorrow for you to show you all of that, how to do it on the calculator. You know, if you have a Chromebook as well, you can download the calculator extension. So when I do this and I just change this number from 0 successes, 0 correct, to 1 correct, to 2 correct, to 3 correct, to 4 correct, to 5 correct, then I'll get all of these values. I'll get 0.237 for getting 0 correct. So 23, almost 24% of the time, when you're just guessing randomly, you'll get 0 correct. Almost 40% of the time, you will get exactly 1 correct. Why are people emailing me? Stop emailing me. The probability of getting 3 correct is a little under 9%. The probability of getting 4 correct is 1.5%. And the probability of getting them all right, even though it might have been you getting them all correct up above, is, what is that going to be? 0.1%. 0.1%. That's not great odds of getting all of them correct. We're going to find and interpret the mean of this distribution. So what I'm going to do is I'm going to take 0 and multiply by probability 1, multiply by probability 2, multiply by probability so on and so forth. So I'm going to take, like I said, I'm going to just, like we had last time, 0 times 0.237 plus 1 times 0.396 plus 2 times 0.264 plus 3 times 0.088 plus 4 times 0.015 plus 5 times 0.00. We'll just round it to 1, save us some time. And I'll save you even more time by doing all that work for you, and it adds up to 1.25. So this means that on average, guessing will get you 1.25 correct out of 5. Wow, that's not great. Recommend you study and prep for your quizzes. Did that just disappear? Let's make sure you can see all of that. There we go. There is a quicker way to do this, and it's specifically only for binomial distributions. We can just take n and multiply it by p. Let's double check and see if that gets us the same thing. So n, number of trials, there's 5 questions. Probability of getting 1 correct is 0.25, and that gives us 1.25. Oh my goodness, when you get to calculus, you'll learn, or pre-cal, you'll learn QED. That is way faster done. That's way easier to do. Find and interpret the standard deviation. You could throw this into Statlet and it'll tell you the mean, it'll tell you the standard deviation. We can calculate it too. Also, only for binomial distributions. There it is. I'm so popular. The standard deviation, which is a sigma, a lowercase sigma. Looks like this guy. Standard deviation, sigma. By the way, mean up here, mu. Back to text. The standard deviation is going to equal the square root of n times p times 1 minus p. I'm going to throw in a square root symbol there right about now. So square root of all of that will equal my standard deviation. So when I plug those numbers in, I get the square root of 5, that's n, times probability of getting something correct, which is 0.25, times the probability of getting something incorrect, which is 0.75. And I'll take the square root of that, and that should tell me that the standard deviation is 0.968. So let's jot down our standard deviation there. And this is the standard deviation, the square root there, and the standard deviation of this variable x, where x is the number of correct guesses, is 0.968. You might be saying, Coach Owings, hi, that's me by the way, what does that mean? So that means that the number correct, that's our x variable, on a quiz of 5 questions typically varies by about 0.968, almost 1 question correct. Questions correct from the mean of 1.25 correct answers. So you're kind of like have a little range here of what you're expected to get, and then most people will be about one question correct away from the mean of 1.25. So most people will fall between a quarter of a question correct and 2 1/4 questions correct. A couple questions down here, and then we'll get to some notes. Sorry, trying to go quickly here. I'm busy, you're busy, we're all busy. Christmas shopping, I'm sure. So we want the probability of getting at most 3 correct. So at most 3 correct is going to be getting 0 or 1 or 2 or 3. So that's going to be x is less than or equal to, I'm going to clean that up a little bit, x is less than or equal to 3 because we want to include 3 there. So we have the probability that x is less than or equal to 3, and we're just going to add up all those probabilities. Got the 0.237, got the 0.396, the 0.264, the 0.088. I'm just going to go copy this. Why not? All 3 of those, and we want to add those together here. I'm going to delete some of that space, and we're just going to add it, add it, add it. That seems awesome. That's not too bad, right? We can do that right quick. And we'll add that together, and we'll say that about 99% of the time, 98.5% of the time, someone will get 0, 1, 2, or at most 3 correct. There's a quicker way to do this on the calculator. Let's say we don't have all that whole table filled out. We can go to, again, second vars, and then it's going to be the other one, whichever one we didn't use above, because we want a binomial CDF now. CDF. P is for exactly. C is for cumulative. 0, 1, 2, 3. Cumulative. We're going to put inputs N, P, and then how many we want to get up to correct, that K. So in this case, we'll have binomial CDF 5.25 and 3, and we'll get hopefully exactly 0.985 or approximately 0.985. What's probability of getting 3 or more correct? So this is kind of the opposite there. And I'm showing you this because it's a little different in the calculator. So if we have all that whole table filled out, 3 or more correct is going to be getting 3 or 4 or 5 correct. So we're going to take all 3 of those and add them together. So that's probability of getting greater than or equal to 3 correct. Probability of x being greater than or equal to 3 correct. I'm going to clean that up and throw a little line underneath that equal sign because we do want to include 3. If you're using this equation editor, you can go find these symbols and insert these symbols as well. I'm just not as good as that as you are, I'm sure. So we're going to go and add 3 and 4 and 5. We're going to add all the probabilities of getting those correct up. And we're going to get rid of those, put our plus signs in, and that total will equal approximately 10%, There's 0.104. So that doesn't include, so this is, this was getting 0, 1, 2, 3, these 3. And when we use CDF, we're able to start at 0 and head up to 3. So I would like to use the calculator and binomial CDF again for number 8 to get this. So if I don't have this table already filled out, I can quickly solve. And so what I can do is I notice that we're looking for 3, 4, and 5, but what CDF does is it starts at 0 and it can go up. So I can use CDF to figure out what 0, 1, and 2 is, and then do 1 minus that CDF of 0, 1, 2. And so let's type up how that's going to look on the calculator. So let's go down on the calculator again. Second vars. And then I want to say this is B. I think this is B. Let's go with that. And we're going to do 1 minus binomial CDF of 5, 0.25 for the probability of success, and 2. So it's going to include 0, 1, and 2 being correct. And then that will give us 1 minus 0.896, which when I subtract will give me about 10% there, which is what I got when I had all three of those added together as well. So let's wrap this up on the next page with a little bit of notes and some hints. So our notes here are going to start with binomial distributions. I don't know where my key is here. Binomial distributions. Binomial distributions. We have a mean or average value, and that will be mu. Let's see if I can throw that mu in there. Give me that mu. Mu. So that mu is going to be n times p. Standard deviation, which is sigma, throw that in there a second, is going to be the square root, throw the square root there in a second, n times p times 1 minus p as well. Let's go get our sigma. So we're going to get a sigma, there it is. Let's start a thing, start an equation there. Put a sigma in, we want the sigma. And I'm going to go draw in a square root symbol as well. So if we want to quickly calculate, we know the number of trials and the probability of success. We can quickly calculate the mean and standard deviation, but we have to go through and determine bins first, and that was our last class chatting about bins. So next, if we want to use a calculator to calculate these things, on the calculator, we're going to go to second vars, and then A, here it is. A is binomial PDF, and this is for exact, like x equals 2 or x equals 3, versus binomial CDF, which is going to be cumulative, 0 up to whatever. I think I'm forgetting some u's there. Cumulative. So if we want exactly a number, then we are going to use binomial CDF. So if we want exactly a number, for example, P equals probability at x equals a number, then we're going to use binomial PDF. If we want less than or equal to, or at most, where we have the probability that x is less than or equal to some number, clean that up in post being right now, less than or equal to a number, then we are going to say that we want to use binomial CDF. And then if we want greater than or equal to, where we have probability that x is greater than or equal to some number, then we use 1 minus binomial CDF, where we have to make sure to use that number minus 1 for x when we're plugging that in. Kind of like how we did right before on this problem here. I used a 2 here to get rid of everything below 3 because I wanted 3 or more correct, so I used the number below it, and I used a 2 there. One quick note here, just a little bit of notes down here, just to remind you that n is number of trials, and p is the probability of success. So let's practice some of these binomial distributions. We'll watch all these videos, super long. I know, I rush, but got to get to that Christmas shopping. emails.